So for metal oxides, the first way of reducing metal oxides to metal is by heating the metal with carbon. And for this reduction by carbon method, only the metal oxide below magnesium oxide can be reduced in this way. So for example, magnesium oxide, calcium oxide, sodium oxide, or potassium oxide, they cannot be reduced in this way. Meaning to say that if I hit magnesium oxide with carbon, if this is magnesium oxide and then I hit it with carbon, the magnesium oxide will not be reduced to magnesium. It is because magnesium, calcium, potassium, sodium, they are too reactive. When they are too reactive, the metal will hold on to the oxygen very tightly. Okay, so the first method of reducing metal oxide would be to heat it with carbon. Now there is another way of reducing metal oxides to metal. Okay, the other way would be to pass through oxygen, to pass through hydrogen, to pass hydrogen through metal oxide when it is heated. So you heat the metal oxide here, and then after that you pass through the hydrogen. So the hydrogen will react with the metal oxide according to this chemical equation. So for example, copper oxide, it reacts with hydrogen. Then it must be heated. The metal oxide must be heated, and then what you get here is copper and water. Actually, this is not water, this is steam, because H2O gas. Okay, so the hydrogen actually break the bond, break the copper from the oxygen, and then after that the hydrogen combine with the oxygen to form H2O, leaving copper alone. And for this reduction by hydrogen method, take note that zinc oxide cannot be reduced by this way. Heated metal oxide are not reduced. So if you put a zinc oxide here, and then you hit the zinc oxide, and then you pass through hydrogen, no reaction. There will be no reaction. Okay, zinc oxide cannot be reduced in this way. But zinc oxide can be reduced by heating it with carbon. Zinc oxide can be reduced by carbon. Okay, so carbon actually is a stronger reducing agent than hydrogen. Okay, I repeat, carbon is a stronger reducing agent than hydrogen because carbon can reduce zinc oxide, but hydrogen cannot reduce zinc oxide. So carbon is a better reducing agent. Okay, so over here, the more reactive a metal is, the more difficult it is to reduce its oxide. An example, potassium oxide. Potassium is very reactive, therefore it is very difficult to reduce its oxide, to separate potassium from oxygen, because potassium is too reactive and it will hold on or bond very strongly with the oxygen. And both carbon and hydrogen functions as reducing agent. Why reducing agent? Because they, for example, carbon strip the oxygen off. So when there is a loss of oxygen, it is a reduction process. Therefore, carbon is a reducing agent and hydrogen is a reducing agent as well. But carbon is a stronger reducing agent than hydrogen because carbon can reduce zinc oxide, but hydrogen cannot reduce zinc oxide. Cannot reduced. Okay, and for oxides below zinc like lead, iron, copper, silver, all these oxides can be reduced by both hydrogen as well as carbon. Okay, for oxides below zinc, they can be reduced by both carbon and hydrogen. And for oxides above zinc, they cannot reduce by either carbon or hydrogen. Okay, Carbon and hydrogen cannot reduce oxides above zinc. Now let's look at reactions of metal compound for the displacement reaction of metals. Now displacement reaction of metals, so there is a, for example, whenever you see a chemical equation that involves two metals, okay, a chemical reaction, there are two metals involved and one of the metals combine with other substance to form a compound. For example, in this chemical equation, you have iron, a metal, you have copper, a metal, and one of the metal, in this case is copper, combined with another substance to form a compound. So in this case would be copper sulfate. So whenever this situation occurs whereby there are two metals, then it is actually a displacement reaction. So in order for you to predict what products you get, what you need to do is to compare the reactivity of the two metals. See which metal is more reactive. Now, in this case, in this example here, iron is more reactive than copper because iron is above copper. Iron is above copper in the reactivity series. So iron is more reactive. So when iron is more reactive, what it would do is it would kick the copper out from copper sulfate. So copper will be alone because it gonna kick out already. So the sulfate will bond with the iron to form iron 2 sulfate. Okay, so iron, copper sulfate, you get copper and iron 2 sulfate. This is copper 2 sulfate. Now, you might be asked to write an ionic equation. Now, how do you write an ionic equation? Remember, in order to write an ionic equation, first of all, you must have a balanced chemical equation. Now, let's see, is this balanced? Yes, this is balanced. So in order to write the ionic equation, what you need to do is whenever the substance is in aqueous state, you have to split it into ions. So one by one, is this iron in aqueous state? It is not. So just write it as it is. Whatever things which is not in aqueous state, you write it as it is. Copper 2 sulfate. Yes, it is in aqueous state. So you split it into ion. Iron 2 sulfate basically consists of, a copper 2 sulfate actually consists of copper 2 as well as sulfate. Alright, these two. So these two are combined together will give you copper 2 sulfate. Then after that, copper. It is not in aqueous state. So write it as it is. And then iron 2 sulfate, this one is in aqueous state. So you split it into iron 2 as well as sulfate. Alright. Then after that, you have to look out for the spectator ions, ions which appear on both sides of the chemical equation. They are exactly the same on both sides of the chemical equation. So in this case would be the sulfate. So these two I cancel off, and then after that rewrite the chemical equation again, and this would be your ionic equation. Alright. So this is how you write ionic equation. Now there is a video on how to write ionic equation. This video will tell you, will give you more example on how to write ionic equation. So I advise you to go and look for this video and watch this video if you still have doubts on how to write ionic equation. Okay, so from this displacement, so this is actually the displacement reaction. So from this displacement reaction, we can see that more reactive metal, which is iron, is oxidized. Now this one is related to your redox chapter. Because if you look at iron, what is the oxidation state? 0. Over here, iron, what is the oxidation state? +2. So there is an increase in oxidation state. Therefore, it is oxidized. Okay, this is related to the redox chapter. Now the less reactive metal, which is copper is less reactive, so it is reduced because copper 2 plus, the oxidation state is +2. This one, the oxidation state is 0. So +2 to 0, there is a decrease in oxidation state, therefore it is reduced. So since both oxidation and reduction happen together in the same chemical equation, we say that this displacement reaction is a redox reaction. Both oxidation and reduction take place together at the same chemical equation at the same time. So it is a redox reaction. So more reactive metals displace less reactive metal from their salt solution. So more reactive metal displace. Displace means replace the less reactive metal, which is copper, from their salt solution. Dia means the less reactive metal. Okay, so Fe replaces Cu, so become FeSO4. Now we look at metal oxide and another metal. Now this metal oxide and another metal, the concept is quite similar with the displacement reaction. So same thing, you have two metals. One of the metal combined with the oxygen. So in order to predict the product, you look at which metal is more reactive. In this case, zinc is more reactive. So when zinc is more reactive, it would displace, or it would kick out copper from copper 2 oxide. So it would kick out copper, so copper will be left alone, and then the zinc will combine with the oxygen to form zinc oxide. This is similar to the displacement reaction. You have to look at the reactivity, you have to compare the reactivity of the two metals in order to predict the products that will be formed. So the more reactive metal forms oxide. So in this case, zinc will form zinc oxide, and the less reactive metal stays uncombined. The less reactive metal in this case is copper, it will stay uncombined. That means it doesn't combine with anything. That means it is left alone.